Today we're going to talk about how to integrate the trig functions. As you can see on my page here, I have a snapshot of part of the formulas page that you get to use on this assessment. Now, the formulas page does give you the derivative of all the trig functions, but it doesn't give you the integral. But what you need to remember is the integral is just the antiderivative. I give you the derivative, you give me the original equation. So what you're going to be doing is you're going to be looking for the derivative values inside of your integral symbol, and that will tell you how to go backwards to the original equations. So let's take a look at a couple of these and how to use a u-substitution if necessary when you do these problems. So let's take the first problem, the first example. We're going to do the integral of the sine of 5x dx. Now, in your book, the 5x might be in brackets, it might not. So we're going to do it just written this way. Now, when you do a u-substitution with a trig function, you need to remember that the u is the argument, what is inside of the trig function. So in this case, u is going to be 5x. Now when you find du, the derivative of 5x is 5 dx. I don't have my extra 5, so I need to put it in. I need to put the 1/5 out front. Now I have 1/5 integral of sine of u du. Here's your du. The rest of it is sine of u. Now take a look at your chart over here, what I've boxed in with the highlighter. Does sine match any of the functions you see in here? Well, actually you can see that negative sine is here. So if the antiderivative of negative sine is positive cosine, then the antiderivative of positive sine would be negative cosine. So that tells me that this will be 1/5 bracket negative cosine of u plus c. Now we need to change back to x's. I'm going to bring this negative outside, making the 1/5 negative, and this will be cosine of 5x plus c. And there is your answer. So this one was a little bit tricky because of the fact that the trig function that I was using isn't exactly correct inside the integral, so we had to make a modification as we did the problem. All right, let's look at another example. We're going to do the integral of 4 secant squared of 3x dx. 4 secant squared of 3x dx. Remember I told you that u is the inner function. So what is the inner function in this case? It is the 3x. It is the argument of your trig function. So du in this case would be 3 dx. So I need a 3, but I have a 4. And I really don't want to stop and think about what I need to multiply 4 by to get 3. I did this in a prior video. I'm just going to take the 4 out. I'm going to put the 3 in that I need, and then I'm going to put also a 1/3 out front with the 4. Now I have my du. So I'm going to bring that down, have my integral. What is out front is 4/3. And take a look at what is left right here. What is that? That would be secant squared of u du. Now stop for a minute and just look at that and make sure you understand how that turned into secant squared of u du. Okay, now we go back to the chart over here. Is secant squared one of my derivatives? And the answer is yes. Here it is perfectly. So if the derivative of tangent is secant squared, the integral of secant squared is tangent. So I now know that this is going to come out to be 4/3 tangent of u plus c. Am I finished? The answer is no. I've got one more step to go. I've got to change it back to x's. So this is 4/3 tangent of 3x plus c. Now, the 3x can be in a bracket. It can be out of a bracket. It, in this case, does not matter. All right. Now, sometimes you will see multiple trig functions within your problem. So let's talk about what to do when that happens. The next problem says 7 cosecant of 4x plus 2 cotangent of 4x plus 2 dx. Two different trig functions. Sometimes it is better to go ahead and refer to the chart before you start. Now, I have cosecant and cotangent in my problem. And in my chart, lo and behold, there is a derivative that is cosecant and cotangent. Now, notice they abbreviate it slightly differently than I do, but it is the same thing. Now, we've got this extra negative in here that we're going to have to deal with. Well, we'll take care of that later. So we are dealing with something that is the derivative of cosecant. So let's go ahead and do our u-substitution. The fact that the argument is the same for both is what allows us to do this problem. If they were two different arguments, this would not work at all. That would be a problem beyond what you would have to solve. So u is the argument, 4x plus 2. So that means that du is 4 dx. I need a 4. I have a 7. Now, I don't need two 4s. You may think that you might because you see two 4x plus 2s. No, that does not matter. You only need one 4. So I'm going to do what I did last time. I'm going to pull the 7 out. I'm going to put the 4 in and put a 1/4 outside. So right here is my du. I have a 7/4 outside. Now think for a minute, what is the inside going to be? Remember that every 4x plus 2 turns into a u. So this is cosecant of u cotangent of u du. Cosecant of u cotangent of u du. All right, now we go back to our chart. Our chart says that negative cosecant cotangent is positive cosecant when you integrate it. So if this is positive, that means the answer is going to be negative. So this means that this is 7/4 negative cosecant of u plus c. Change it back to x's. So the negative comes out, joins the 7/4. Cosecant becomes 4x plus 2 plus c. One more problem that I'd like to do for you, and I believe I have enough room to do this problem. This problem says the integral of 16 cosine of 8x minus 2 sine of 2x dx. 16 cosine of 8x minus 2 sine of 2x dx. All right, these two trig functions are subtracted. They're not multiplied like the previous problem. Now I'm going to scroll my paper up here, and I want to point out that all of the trig functions here are either a single trig function or they're two trig functions that are multiplied. Nothing is added or subtracted. So when given a problem like this, what you are basically going to do is you are going to break this into two separate problems. So you're going to basically do 16 cosine of 8x dx minus 2 sine 2x dx. You're going to do each one individually. Why? Because they have different arguments. You cannot use the same u-substitution for both, just like the prior problem. Since the prior problem had two 4x plus 2s, with this one here and this one here, we could use a single u. Here, the arguments are different. We have to use separate u's. So that's what I'm going to do now. So I'm going to take the left integral, work it all the way out, then I'm going to take the right integral and do the same thing. So I'm going to do my u substitution off to the left-hand side here, just because I'm running short on space. What is u for the first integral? It is 8x. So du would be 8 dx. Now, this one is going to be done a little bit differently. I have 16, which happens to be a multiple of 8. So basically what I'm going to do is I'm going to break 16 in my head down to 8 times 2. I'm going to put the 8 with the dx, then I'm going to put the 2 outside. Oops, that's a yucky 2. Let's try another one. Okay, now I have my du. I have a 2 outside, and I have cosine of u inside. All right, so now, where is cosine in my list? Cosine, right here, happens to be the integral of sine, plain sine. So this will become 2 sine of u. And I'm not going to put the plus c. I'm going to wait till the very end and do, well, actually, let's go ahead and put it plus c. And then that becomes 2 sine of 8x plus c. So that one's done. All right. So now we have a minus here. Need to do another u substitution for the other side. Well, you know what? I've decided that I want you to do it. So pause the video and do the right-hand side's u substitution yourself. See if you can get the correct answer. Okay, let's take a look at this one. So u in this case would be 2x. du is going to be 2 dx. Well, look, I've already got my 2. So I'm basically going to move it down here. It's going to become my du. I have the integral of sine of u. If I go up to my chart, the integral of negative sine is cosine, so the integral of positive sine is negative cosine. Now, you can look at this one of two ways. What you could do is you could take this negative and put it inside the integral over here, and then you have what you need. Now it is negative sine, and that integral will be a positive cosine of u plus c. I have plus cosine of my new u, careful, 2x plus c. Now, if I were to combine those c's, is that really 2c? Well, not really. C is what I call a magic C. Until C is evaluated, it represents a constant. I don't know what it is, but it's a constant. So the true final answer here, we take this C and this C, all C's combine to make a new C. So my final answer is 2 sine of 8x plus cosine of 2x plus just a c. I haven't evaluated c, so this magic c, c plus c in this case, is just another c. All right, ponder that for a little while. If you have a question about it, feel free to email me and ask. Good luck with this assignment. Let me write down what it is. If you are doing the Griffith book, this is section 4.4, which is on page 115. If you are doing the Delta book, it is section 20.03, which is on page 352. 1 through 11 in the Griffith book are pretty straightforward problems. They're not that difficult. When you get down to 22 to 30, you have got to go to your formula sheet and look and see if you can change these trig functions into something else that they equal that is in this box right here. As they stand, they are not here. You cannot integrate these yet. Some of these are going to be very, very tricky. So, if you need help with them, please feel free to ask and email me. All right, good luck with this assignment, and like I said, let me know if you have any questions.